Welcome. Today we are going to be talking about building a Selenium Grid environment with Docker. And what that means is we're going to be doing a hands-on guide to building a Selenium Grid. This is going to be very tutorialish, very beginners. So bear with us if you know how to use Docker, which hopefully you do from the previous presentation. And hopefully you'll learn something new about Selenium today. So what we will cover. So today we're going to talk to you about what is Selenium, what is Selenium Grid, some of the benefits of using a Selenium Grid, also look at using Docker and combining the two using Selenium Grid with the Docker environment, Docker container management. And then we're going to walk through a complete tutorial on building a Selenium Grid using Docker. So what is Selenium? Well, in a nutshell, Selenium is a suite of tools that developers and testers can use for automating their web browser testing. So this can be for any web-based application that runs within a browser. It can be used to create robust browser-based regression automation suites and tests. It can run in many browsers and operating systems. It can also scale and distribute scripts across many environments. And it can be controlled by many programming languages and testing frameworks. So this could be like Java, Groovy, Ruby. It also works for most browsers, traditional modern day browsers like Chrome, Firefox, Opera, IE, Edge. And it also has some headless browsers like Phantom.js and I want to say GhostDriver or Ghost.js. And there is essentially a headless HTTP unit test browser for just testing, which no one really uses anymore, but it's still out there. So what are the benefits of using the Selenium Grid? Well, the Selenium Grid allows you to scale your tests by distributing them across several machines, allowing for parallel executions. This is similar to creating multiple virtual machines and testing your application on individual VMs or on individual computers. Instead, you can actually script this and have the Selenium Grid do it for you. So again, instead of testing on one machine, you can now manage multiple environments from a central point. So what's unique about this, though, is it gives you the ability to test, say, IE6 or IE7 on Windows 95, Windows 7, Windows 8, Windows 10, or test the multiple different variations of Firefox, test different versions of that, or test different versions of Chrome. Or if you still have users running Safari on Windows, you'll have to go back to Windows 7 to find a version of Safari that still runs on Windows. You can also use custom hooks to leverage your instance, so you can minimize the maintenance time for the grid. So you can quickly spin up and down nodes in a grid within seconds without having to build full customizable VMs, which takes time. And it also takes a lot of time to spin those up based on resources. So what is Docker? Docker, in a nutshell, is a tool designed to make it easier to create, deploy, and run applications by using containers. If you want to know a lot more about Docker, go look at our previous presentation on learning Docker. In this case, we're going to assume that you kind of went through the previous presentation, so we're going to skim over a lot of the installations and setup of Docker, but we're just going to jump into the meat of using Docker with Selenium. So why do we want to use Selenium Grid with Docker? Well, there's, again, the huge benefit of using Docker, and because it has a large capacity to scale, so we can quickly scale up multiple nodes in the Docker instance. It gives us lightweight containers where we don't have to load up an entire operating system. We can just load up a single node with shared resources and have 5 or 6 Firefox nodes in the queue so that we can actually test 5 different tests using Firefox or Chrome or IE all at the same time. And it's easy to recover if Selenium goes off the rails, and it often does. So Selenium has this habit of crashing from time to time because it's a container. And a lot of times, what will happen is your browser could lose connectivity with the internet, or the browser could lose connectivity with the Selenium server. So sometimes it's a lot easier to just drop a node and bring it right back up instead of actually debugging the problem. Because 9 out of 10 times, the issue is some type of connection or connectivity issue within the Selenium kind of gobbledygook of the grid versus Docker or the VMs. So it's just faster to drop it and start over. So to get started today, we're going to need to get a few things. So we're going to need to get our hands on Selenium Grid. We're going to need to get Docker, and we're going to have to get some containers. So let me jump out of the slides and actually go look and actually go start our demo. First thing we need to do is start Docker, and I believe he is started. Yep, he's up here, and he's running. And we'll open up kitematic, which is awesome because it shows you which containers you have running. And right now I have no Docker containers running. So we'll open up the command line interface for Docker. Let's go to my Docker folder. All right, so right now I have a Docker compose, which is a prescript for running our Docker suites. We'll come back to that later. So first things first, if you want to get started, you need Docker. So to get Docker, you can go out to docker.com and download the free Docker Community Edition. You can sign in. You can also register with the Docker repositories, so you can actually upload and share your Docker containers with the rest of the world, or download other Docker containers that people have shared in the Docker Hub repositories. For Selenium Grid, if you go to seleniumhq.org, this is everything Selenium, so you can actually get the standalone Selenium IDE if you still have a version of Firefox that can run it. Bear in mind, after Firefox, I want to say 48, Selenium support has pretty much dropped off the face of the earth for Firefox as far as the IDE is concerned, simply because Firefox is going through a huge overhaul of the Firefox browser. So a lot of the security features have disabled a lot of the capabilities for the plugin to interact with Firefox. So what you'll probably be focusing on more is getting the Selenium WebDriver, which is the libraries for you to use Java, .NET, C#, whatever, to actually communicate with the browsers to run your tests. And then you'll also need to get Selenium. So between the two, that gives you just about everything you need. And then the other thing is the Selenium Grid. So if you go out here to github.com/capital Selenium, capital HQ /lowercase Selenium /wiki/grid2. Sorry, that's a mouthful. I'll include that in the blog. But here is where you find everything about the grid and the WebDriver. So it gives you some examples on using Java, and there are C# examples out there as well. And the other place you want to go is the Selenium HQ /docker-selenium. This is a pretty cool little GitHub location. This contains all your base nodes for kicking off the Selenium Grid. And it also gives you some standalone Docker containers so you can actually run and test your tests in the specific Chrome and Firefox before actually pushing it to the grid. So you always kind of want to start with one, make sure it works in one environment, and then the other, and then you can propagate it up to the grid, and then you know things should work. If things don't work at that level, then you know you have an issue with the hub. Okay, so next, now let's go back over here. All right, so the first thing we want to do is we want to start with the standalone. So let's make sure Docker is running first. So we see Docker's up here, but let's make sure we can actually connect to it. Docker PS. Okay, it's running, but we have nothing currently running. So if I do Docker run -d -name se-p, we're saying the ports for 590-p. We're going to set the Firefox port to be on 4444 and run that. Oops. If you get this, it's simply because you're running into an issue where 590 is currently binded. I'm running on a Mac, and I found that that port is currently in use by something. So to fix that, you can just change your mapping port here, 5901, and that one is also in use. So let's try 5902. Another conflict. Oh, SE is already in use. Sorry. Clear. Docker container queue. Yep, I have one container running, so sure enough. Docker stop. Okay, now that's not running, so let's try that again. There we go. And to make sure he's running, we can do Docker PS, and he started. Now, if I go look at Kinetic, it takes it a second to refresh. So we can click here, there's SE, there's our container logs. If we need to see what the logs are, we can also do it from here. We can do Docker logs SE. And as you can see, those are the same logs that are here. Okay, next thing we want to do is, I also ran the standalone Firefox debug. The debug containers that live out here are really cool because what they allow you to do, open up a new tab, is they allow me to actually VNC to my instance. And then it'll open up a VNC connection to your browser. So if you actually run a test through here, you will see it run interactively within your VM. So that's one way to run it. So if we go over here, we can also hit localhost 4444. We'll say, oops, that may not be what you wanted to do. Let's go look at the console. And we have nothing running in the actual grid console. Because right now we're just running the standalone. So that's how you kick up a standalone. So now let's go back over here and we'll do, let's clean up our debug instance and actually build one that we actually can use. Right, Docker stopped, kitematics, stopped. Yeah, let's remove him. Now, in a real world instance, you're not going to be going behind yourself and cleaning up your environment as often as I am doing here. This is just because I want to keep my local instances clean. All right, so next, let's build a Selenium grid with 3 containers. So the first thing we need to do is we need to get the Selenium Hub, this guy here, from the Selenium GitHub. Let's go back over here, and we can do Docker pull Selenium Hub. Now I've already pulled it down, so it's not doing anything. If you did not have it, it would take a minute to download all the dependencies for that image and then build the image. Then we have the Docker Firefox node. So let's go see what we have. So we have Docker images. And oops, if I spell things right. And image. Docker, and I still can't type. There we are. Let's get that a little bit wider. So here we are. We have our standalone Firefox debug that we started with. We have Firefox, we have the node for Chrome, and we have the hub. So now, let's start the hub. So Docker run -d, you give it a name, hub, -p Selenium Hub. Now if you notice here, I did not give it the ports like we did with the debug. So here, when we specify the name, we also specify the mapping of the ports. This time I did not because I wanted to show you what happens if you leave it blank. So let's go over to kitematic. Refresh. Okay, there's Hub. So by default, it's going to go grab an available port and assign it to your 4444 Docker port. So now if I go look at localhost 32772, again, it says Selenium Grid Hub. This is actually a grid now, so the console will come up. So we now have our console. We can view our configuration, and here's all of our settings for our hub. All right, so we have a hub, and the other things we can do. So if we look at Kitematica again, so here's our hub here. It says Selenium Grid Hub is up and running. Nodes will be registered to the grid register at 172.17.0.2:4444. We will never hit this IP address and ports directly. We will always be using the localhost 32772. Back over here. So now, if I click Docker log hubs, we see the same information here. If we want to get more information on the Docker container, copy the container ID, and then do Docker. Let's back. And the ID, and again, I misspelled that. There we go. So here is all the information about the server. So as you can see, we have the ID, when it was created, its path, its current state, running, paused, some of the other things that are important to note. Your shared environment paths, network settings, here we are. So here is where you can find what the mapping is. So we're mapping port 4444, host IP 0 is localhost, and the host port is 32772. So that's how you find this on the command line. But if you're running Windows or Mac or Linux and you have the Docker and Kinetics installed, you can also get that by clicking on the actual container and looking under the home IP and ports. So you'll see the same mappings there. So next, so we have a grid, but currently we have nothing in the grid. So let's add some things. So let's start by adding Chrome. So again, drrun-d link, we're gonna connect, we're gonna link this container to our grid. So we're gonna put it to the hub, -p name, we're gonna call it Chrome, and we're gonna use the Selenium node Chrome, which is gonna pull from this one right here. Kick that guy off. And while we're here, let's go ahead and just skip a step, and we'll just go ahead and do Firefox as well. So they're both kicked off. If I go refresh my grid, look, I now have 2 instances running in my grid. I can then do Docker logs Chrome, Docker, and there's my output. Node is registered. Awesome, it's ready to use. And same for Firefox. Same thing, node is ready to use. Now, if you want to stick on command line, these are the commands for that. I like jumping back and forth because if you go out here, you'll find that Kinetics is really nice because you have your current container logs. You can see the exact same information here. And here's our hub again. So clean this guy out. All right, so now we have a grid. We have 2 nodes running in our grid. So how do we test that our grid is actually up? How do we actually push something to the grid for testing? Well, for that, you need a test. Well, since I do a lot of work in Java and TestNG, I am going to show you how to create a simple Java test to do this. So I already have it pre-built, but since we're doing pretty good on time, I'll actually walk you through the whole setup. So we'll create a new Maven project, and we'll just use the defaults. Quick start. Selenium Grid demo 2. And that will quickly build our environment. Resource folder. And we want to also add testng. I like testng. It's built on top of JUnit and it has lots of additional libraries for Java, which makes life a lot easier when creating tests. Okay, apply and close. So the first thing we need to do is we need to include our dependencies on our POM file for unit our testng and Selenium. So those dependencies go here. You replace JUnit with org.testng and Selenium hq.selenium. And I get rid of the dependencies. And if you're ever unsure of what version to use, you can always go out to the mavenrepository.com. Then you can type in testng. Click testng, and it will always tell you what the latest is. Be careful using the latest and greatest. Always check the usage and when it was deployed. Sometimes using the latest and greatest can be tricky. I've been bitten a few times jumping to the latest and greatest, not realizing that, oh, it came out like last week. So there's a lot of bugs that need to be worked out. And as you can see here, in February, the 6.14.2 came out. A lot of people jumped to that. Some people found some bugs, so they quickly jumped to 14.3. And it's just kind of interesting because really they kind of skipped over the 14.1 because 13.1, they used the same build from 13. So they really didn't have a lot of changes between these two. But just because it's a new year, they always increment it for each year for the second number. All right, so we've got testng and then Selenium HQ. You can download the Selenium server, API, Firefox drivers, other support. There's lots of little dependencies in there. And there's that HTML unit driver I was telling you about. That was that kind of not so useful or used in-memory browser testing that a lot of people use. Okay, so we have our POM. Save. Awesome. Okay. Delete our old test because we don't need him anymore. All right, so we now need a new class file. So let's come in here. We have app. Okay. This really isn't a Spring Boot app that we're going to need. So we're going to create a new class. We're going to call this one Selenium Grid Test. Finish. Copy the code over here so we don't spend a whole lot of time dealing with typos. Dependencies. There we go. After I ran the POM file, I apparently interrupted the build. So when you get errors like that, when you know that you've installed the plugins, right-clicking on a project, do Maven, and update the project will pull in the missing dependencies, as long as you have them defined in the POM file. So in here, here's our test file. So I've created a couple features. So before test, test, and after test are just three levels of the testing process. So before test is where we kind of construct and predefine any setups or configuration pieces we need for the test. The test portion itself is where we actually do the testing. And then the after test is where we tear down, or in this case, we clear out the driver and close the browser. So in our before test, we want to launch our browser. We're going to set, right now, we're going to hard code which browser we kick off. We're going to call the site calculator.net. This is a very cool test site if you ever just want to test to see if something works. It's just an online calculator. We're going to click Math Calculators. We're going to come in here and we're going to do the percent calculator. We're going to populate these 2 percents and we're going to then calculate it. So we're passing in Chrome. We're going to set our URL that we're going to actually hit to test here. And then we're going to set the actual node URL in here. Now that node URL is the one we had in our browser right here. So the localhost 322.772, we need that. And we'll paste it here. Now, where did I actually get this link here, the HTTP localhost 32772? Well, that's the actual host to the grid. But what's this wd/hub? Well, if we go out to our actual container and look at the logs, so when we registered the nodes, we see here that they both got registered. But then if you come up, it says, hey, client should connect to HTTP 172.17.02. Well, we can't hit that because that's actually on a container. It's on a self-contained machine. In order to get to that, we have to use our mapping, our access URL. So in place of this URL here, or this host and port, we're going to replace it with localhost, and then we're going to put in the wd/hub, which we have here. And we will do the same thing down here. Then we define the Firefox options, then create a remote driver instead of using the Firefox driver, which if you were just going to connect to the Firefox node directly, not in a grid, you would change this to Firefox WebDriver. Same with the Chrome, you would change this to Chrome driver. You pass in the URL that you want to connect to once you've connected to the node. So here's our node, awesome. What options do we want to pass into it? So if we want to change any of the Firefox configurations, we pass that in here. We then set the timeout to 10 seconds to pause to give it time to open up the browser. Then we're going to tell the driver to navigate the browser to our URL, to this URL, to thecalculator.net. And then we're going to maximize the window. And then we'll continue on with the test if we were doing Firefox. If we were doing Chrome, in order to maximize the window, we actually pass in an argument of start maximize. This will open the browser and maximize it automatically for us. So when we come down here and call remote WebDriver, new URL options, manage timeout wait, when we do navigate to URL, this right here already, when we call this, opens it up maximized. And then if we try to pass in anything else, we get the browser is undefined. So what are we actually going to do in this test? Well, we're going to go out to the calculator.net. We're going to look for a link that contains math. Then we're going to click it. And then on the next page, we're going to look for a link that says percentage calculator. We're going to click that. Then we're going to look for an element by ID for the first parameter. And then we're going to send it the number 17. And then we're going to click on or find another element by ID called cpar2. And we're going to pass in the value of 35. We're then going to do an XPath lookup to click the calculate button, which should populate the third field with the text, which will be displayed on the screen. So we then do driver find element by XPath again. We look for the XPath for the text that will be displayed. We get the text, and then we evaluate it. So we system that out. The result is this. The result equals the result passed. If it does not, we say it fails. And you could also change the system.outs to assertions. And then we close the browser. So if we right click on this guy, run test. Yes. We're executing Chrome. See it here. And if I go out here, you'll see the Chrome little icon here is clouded. If we go look at kitematic, we see that we actually have a connection to our server. So we're actually running something, and this will take just a minute to run. While that's running, pull up the next little piece here. So all the setup work we did behind the scenes here to pull down all the nodes, to pull down the hub, to start the hub, we can actually put all that into a single Docker Composer script. So if I look at this guy, as you can see here, we define the hub as the image, Selenium Hub. We map the ports to 4444 and 4444. We also define a Firefox and Chrome image as well, and it will download the hubs or download the nodes and then map them to the hubs. So if I actually check out if you have Docker Composer installed, you can do Docker Compose up -d. And now if we go look at kitematic, there's our new hubs. And as you can see, I didn't have to type anything. It was just click, boom, done. Pretty straightforward. And then when you're done, you can do Docker Composer down, and it will shut everything down for you. And we have our original 3. It's taking a little longer than I'm comfortable with, so we'll leave it going for just a minute more. All right, so now, say I wanted to scale up. So if I do Docker Composer up, let's say I want to scale. Let's do Docker Composer up first. All right, so now we have our 3 containers running again. There they are. There we are. So the test finished on our initial one. So the result was 595. It passed, and everything looks good. And if you run test ng, you get a nice little interface like this where you can see what passed or failed. And then the other thing you get by using test ng is in the test output, you get this nice HTML breakdown of your test. And there it is. You can click and you can see all the details of your test. All right, so that's testing in a nutshell here to test this. If we want to do Firefox, we just change this guy to Firefox. And then rerun him. And again, while he's running, we'll come back over here. So we've run our Docker Compose. So it's now up. But here's the cool part. So if I do Docker up -d, but I add an additional parameter of scale, and let's do Chrome because I'm not running that. It's Firefox. And we do scale Firefox. We tell it which node to scale. We can then tell it how many instances to kick off. Boom, it just threw up 5 more instances of Firefox. So if I come out here and I refresh, boom, I now have 5 instances of Firefox. And if I go look at my grid node here at local 4444, and click my grid, I now have 5 instances of Firefox, 1 instance of Chrome. It was that quick to spin up a new node. And then it would say, oh, okay, I don't need that anymore. I just need 1 again. Okay, we're down to 1. So now the node has to clean up, and then the grid will drop back down to 1. And then if I wanted to, I could do the same for Chrome. Give that guy a second. And we now have 5 instances of Chrome. So when this guy refreshes, we now have 5 instances of Chrome and 1 of Firefox. All right, so let's go back over to our other console here. So, well, the Chrome one was running. The Chrome guy was grayed out, and Firefox is probably finished by now. So yep, it finished. So he's currently available to be run. So now I'm going to switch back over to my original example here and show you an additional piece you can add to your test environment. So over here, we had our Selenium Grid test, and the additional file, which is why we needed resources, you can create what's called a testng script file. And in here, you can build a test suite. So now instead of us running one test at a time, we can actually define a test suite and run multiple tests at a time. So here I have it where it's going to run Firefox test 1, 2, 3, and then run a Chrome test. Well, before I run that massive file, I'm going to simplify this and just run it with one. Okay, so Chrome, and I need to make sure I'm using the right port. And all looks good. Okay. Everything compiled, good. All right, so now if you right click on testng, you run as testng suite. It's running. Our node's gray. Go look at our log. We're hitting our server. It also tells you what we're calling. So we're passing in the browser name, Chrome, max instance 1, platform Linux, the version, the application name, again, the platform. And that'll take a moment to run there. As soon as he's done, we'll get our information, and then we'll run the Firefox test. So to define a test in here, you create your suite, you give it a name, you tell it to run parallel. You can run them parallel, you can run them in sequence, you can run them randomly. I like running them parallel. You can also define how many tests run at a time by setting the number of tests, 1, 2, 3, however many. Parallel, what's kind of cool with this is it will run them as, basically it will queue them up if the resources aren't available, and then as they become available, they kick them off. After a while, though, they do timeout. So we set up our names. So we have 3. We have Firefox 1 and 2. All of these are going to call our Selenium Grid test, and we're passing Firefox as our parameter. So our previous example, we were hard coding the parameter browser. Here, you can pass it as a parameter from your testng file. So you set it as parameter browser. So we tell it which XML field to pull the value from. We then have to define a parameter in our method to receive that parameter. So if you have multiple parameters, you basically just create the multiple parameters in the method here. So then we define our string URL for calculator. We tell it the node is going to be the localhost hub. So we'll pass in Firefox. So it should call this here 3, 4 times, 3 times. And then we'll do our calculate, and then we'll close. Free up some of my resources here. There we go. That's why it was taking so long. When you're doing this locally, you have to be careful how many nodes you kick off because they do eat up resources. You are essentially running micro VMs or little container versions of VMs. So the more you run, the less memory you actually have. All right, so this guy finished. Everything's hunky-dory. We got test pass. Great. So now I've got my testng. I've got 3 tests queued up. Let's see what happens. So now run as testng. Executing Firefox. And he passed. Look at our hub. Ran him. Great. All right. And then what happens if we try to pass in a test that doesn't match a value? Oops. There's our container here. If we were trying to run IE, which since I'm on a Mac, IE doesn't exist. And oh, it tried to run Firefox. Why is it trying to run Firefox? Oh, sorry. Running the wrong file. Run testng, run as test suite, and it fails. So we'll look at our failure. If you click the suite, the browser type is undefined. All right, so let's go back and rerun that previous example because I just realized I made a faux pas. There we go. All right, now if I run the testng file, not the Selenium test grid, it will try to run all three of these tests simultaneously. But we'll have one small problem with that. So right now, if you look at the grid, we only have one Firefox instance available. So what's going to happen is the other two are going to queue up till he's available. Run that. So as you can see here, we have three requests waiting on a slot. And right now, it looked like the previous one had hung. So once he times out, these should kick off. But chances are, because whatever I kicked off that hung him is going to cause these guys to all time out. All right, so let's kill this guy. Something got him hung. So give him a second here. I want to make sure he cleans up. And as you can see, this is a good reason why people go out and just drop and rebuild nodes. Because sometimes they just hang up on you. They get squirrely. And you can spend a lot of time trying to debug it or just drop it, restart it, and chances are you're going to fix your issue quickly. 2 requests for you. Okay, so cool. So by restarting the node, the first request that was hung in there seems to have gone away, and it's now trying to process the 3 that I passed from here. So if I want to just spin up other nodes, all I have to do is keep renaming the name. So I just now added 2 additional Firefox nodes. And as you can see, the queue is now empty and all 3 are now processing. So that's the nice part about using the Selenium Grid with Docker. So if you see that you have a large queue of requests coming in to hit the grid, you can just quickly spin up a bunch of containers and a bunch of nodes for those tests. And then once the queue is finished, you can basically release all those nodes, freeing up resources. So say we want to do cross-browser testing right now, great. So we have all the browsers loaded, we hit them all, we test them all when we're done, cool. We drop all the nodes but 2, and then say we wanted to do a full regression suite test using Phantom.js. Well, for that instance, then we would spin up 100 or so Phantom.js instances and then kick off a whole bunch of tests against Phantom.js, which is essentially a headless version of Firefox, a very stripped down version of Firefox. So that was the demo. Let's wrap it up. So we've talked about what Selenium Grid, and Docker, what they are and kind of how they work together. We've looked at the benefits of using the Selenium Grid and Docker, where you can quickly spin up nodes in order to run multiple tests in an environment. And if something goes wrong, like we ran into here, you can quickly drop everything, bring it back up, and boom, you're ready to go. And then we also walked through a complete tutorial of how to build a Selenium Grid with Docker. And I even threw in how to build a testng test in Java and kick it off to actually test, or to actually run a test to test your Selenium Grid and Docker instances. Give you guys a little quote here. Only conducting performance testing at the conclusion of system or functional testing is like conducting a diagnostic blood test on a patient who is already dead. Scott Barber. Thought this was kind of fitting for those of you who are in the testing world. There's a lot of cases where you get to the very end of the sprint cycle and it's like, hey, let's do our testing now. Okay, so we have what? A couple hours before we go to production for us to test everything? And not really a great idea. Which brings us to the end of tonight's lesson. Thank you again for listening in. And if you wish to follow us or contact us, check us out at info@developer.com. Check us out on our website, developer.com/contact us. We're also on Twitter at developer, and we're also on Facebook at facebook.com/developer. Have a great night and see you next time.